What if a comet entered our solar system and defied every rule? Imagine an object that seems to break the laws of physics, with a feature that looks more like engineering than nature. This isn't science fiction, it's a thought experiment grounded in a flood of strange data from real interstellar visitors. We're about to explore a hypothetical scenario based on real science that pushes the very boundaries of our understanding. Let's delve into this possibility together. The Chilean frame. It all starts with a single, unexpected image. Imagine an amateur astronomer, much like the legendary Gennady Borisov who discovered the first confirmed interstellar comet from his backyard Margot Observatory, peering at the sky from the clear darkness of Chile's Atacama Desert. The date is October 20th, 2025. Her equipment, a 150mm refractor, is pointed at the coordinates for a newly tracked interstellar object, 3I/Atlas. What comes back from her cooled CMOS camera after a 60-second exposure isn't a textbook comet. The raw data, captured under pristine, verifiable conditions with atmospheric seeing logged at an exceptional 0.7 arcseconds, shows something impossible. This isn't a blurry social media rumor, it's a hard data point from a credible observer. The coordinates match NASA's official Jet Propulsion Laboratory tracking. The equipment metadata is clean, and the image is perfectly sharp. And there, aimed directly at the sun, is a perfectly straight, highly collimated jet of material. This single frame from a small, converted farm building becomes the most important astronomical image of the decade, kicking off a firestorm of debate and challenging the very foundation of cometary science. Comet Physics 101. To truly grasp how radical this new image is, we need a quick refresher on standard comet mechanics, a model that has held up since astronomer Fred Whipple proposed the dirty snowball hypothesis in 1950. Comets are essentially deep frozen reservoirs of ice, dust, and rock. As they approach the sun, solar radiation heats the surface, causing ices to sublimate directly into gas. This outgassing creates the coma. Then, the sun's constant outward pressure pushes this material away. This pressure has two components. The solar wind, a stream of protons and electrons moving at 400 kilometers per second, which interacts with the gas, ionizes it, and carries it straight back along interplanetary magnetic field lines to form the ion tail. The second component is radiation pressure, the gentle but relentless push of photons themselves, which pushes the larger dust particles away. Because the dust moves more slowly, its path is influenced by the comet's own orbital motion, causing the dust tail to be broad and curved. This two-tail structure is a universal signature. No matter the comet's composition or origin, the rule is absolute. The sun always pushes, and the tails always point away. The sunward jet. Now, let's go back to that Chilean frame. It throws the rulebook out the window. Instead of a fuzzy coma and majestic tails pointing away from the solar glare, the image of 3I/Atlas shows something entirely different. The nucleus is a sharp, dark point. The surrounding coma is strangely faint with a measured magnitude of only 18.5, far dimmer than expected. But the most shocking feature is a narrow, focused column of material, no more than 2 arcseconds wide, extending from the nucleus directly toward the sun. It's not a tail. It's a jet. Seasoned comet observers, like the renowned planetary scientist David Jewett, would find this image deeply unsettling. The expected anti-solar tail is completely missing, replaced by a feature that seems to violate the basic principles of solar-driven outgassing. The object is actively resisting a 400 km/s solar wind. The image confronts us with a stark contradiction. An object that should be fleeing the sun's power appears to be pointing something straight at it. This single observation demands an explanation, and the easy answers simply don't hold up. Breaking the rules. So, how badly does this image break the rules? Completely. The standard solar sublimation model predicts that as a comet gets closer to the sun, it gets more active. Light curve models predicted 3I/Atlas should be at a visual magnitude of roughly +8 by now, but it's hovering around a faint +14. That's a difference of 6 magnitudes, which means it is reflecting almost 250 times less light than it should be. Experts like Dr. Matthew Knight of the United States Naval Academy find this baffling. This implies an incredibly low albedo, or reflectivity, of less than 0.04, meaning its surface is darker than asphalt, possibly coated in complex organic molecules called tholins. Yet, this dark, quiet object is somehow powering a highly energetic jet. A disintegrating comet usually turns into a diffuse, messy cloud, not a sharply defined structure. The object is simultaneously too faint to be considered healthy, and too structured to be considered dead. This is a profound contradiction, exhibiting behavior that seems to mutually exclude itself, and it has left our current models entirely stumped. The gauntlet. Every extraordinary claim in astronomy must survive a gauntlet of mundane explanations. The first suspect is always geometry. Sometimes, from Earth's specific vantage point, dust left in a comet's orbit can create an anti-tail. However, anti-tails, studied extensively by scientists like Michael S. P. Kelly during NASA's EPOXY mission, only appear when Earth crosses the comet's orbital plane. On October 20th, Earth was still over 4 degrees away from the orbital plane of 3M Atlas, making a prominent anti-tail highly improbable. More importantly, anti-tails are always broad, diffuse sheets of dust, not the tightly focused jet seen in the image. The next suspect is a transient event, like a pocket of volatile ice erupting. But these outbursts are chaotic and short-lived, rarely lasting more than a few rotations of the nucleus. The sun-facing feature in the Atlas data is persistent across more than 4 hours of observation, making a fleeting eruption unlikely. Finally, atmospheric distortion is ruled out by the observatory's logs. The stars in the image are sharp, proving the sky was stable. After running the checklist, every conventional explanation falls short of explaining the hard data. Chemical anomalies. If the physical appearance is strange, the underlying chemistry is even more baffling. Spectroscopic analysis of 3I Atlas, led by Comet physicist Dr. Jonah Lau, has revealed a composition unlike anything ever seen. The ratio of carbon dioxide to water is nearly 8:1. For perspective, cometary experts like Dr. Mike DeSanti at NASA have shown that for most solar system comets, this ratio is less than 0.3:1. This extreme CO2 dominance suggests 3I Atlas formed in a place far colder and more carbon-rich than our own Oort cloud. But it gets weirder. Preliminary spectra hinted at the presence of nickel, but with a conspicuous absence of iron. This has no known precedent. This might suggest the object formed in a region of a protoplanetary disk where elements were fractionated in a way never before seen, perhaps in the ejecta of a very specific type of supernova. This bizarre, hyper-volatile chemistry might explain some unusual outgassing, but it certainly doesn't explain why that outgassing is organized into a single, stable, sunward beam. It only deepens the alien nature of the object. Retrograde path. The object's path through our solar system is, another major red flag. 3I Atlas is on a retrograde orbit, with an inclination of 110 degrees, meaning it's traveling against the flow of planetary traffic. Its immense speed, with a hyperbolic excess velocity, measured at 32 kilometers per second, absolutely confirms its interstellar origin. It's a tourist here, not a resident, but its trajectory, combined with its estimated mass, raises some really fascinating questions. When scientists like Avi Loeb analyzed the first interstellar object, Oumuamua, its slight deviation in trajectory led to the hypothesis that it could be an artificial object, a solar sail. Now, with 3I Atlas, we have a different anomaly. It's not a subtle acceleration, it's a visible, persistent structure that seems to defy solar forces. This sun-facing jet, in the context of its exotic composition and retrograde path, forces us to consider possibilities that stretch natural explanations to their breaking point. Could this jet be a functional feature perhaps, as propulsion expert Mason Peck has theorized in other contexts, an engineered structure for orbital maneuvering? Perihelion blindness. Here's the deadline. On October 29th, 3I Atlas will reach perihelion, and at that exact moment, it will be hidden from Earth, passing directly behind the solar disk. This conjunction isn't just a scheduling inconvenience, it's a period of total blindness for every ground-based telescope. The sun's glare creates a zone of exclusion for optical astronomy, typically inside about 12 to 15 degrees of solar elongation. This is the one moment when any sudden change could occur completely undetected. Experts on solar system plasma environments like Dr. Geraint Jones know that a powerful coronal mass ejection, or CME, could erupt from the sun at any time. If 3I Atlas were to be hit by one during conjunction, The blast of magnetized plasma moving at over 1,000 kilometers per second could strip material, impart momentum, or even trigger catastrophic fragmentation, and we wouldn't see it happen. It's the point of maximum stress, maximum danger, and maximum mystery, and it's happening when our view is almost completely blocked. Space Watchers. Once 3I Atlas emerges from behind the sun in early November, an army of telescopes will be waiting, the scientific community will be on high alert, and the checklist of what to look for is clear. First is photometry. A sudden jump in brightness could signal a natural outburst, while a steady fade, without a growing tail, would be highly unusual. Next is morphology. Does the comet finally grow a classic anti-solar tail? Or does the bizarre sunward jet persist? Programs like Pan-STARRS, directed by astronomers such as Ken Chambers, are designed for this kind of monitoring and can detect objects down to a magnitude of 24. They will search for any fragmentation, the appearance of smaller companion objects breaking off the main nucleus. Even tiny, almost imperceptible shifts in its trajectory, measured with a precision of milliarc-seconds, will be meticulously tracked by professional networks. Every new piece of data will be scrutinized, compared, and debated by experts like comet dynamicist David Nizvorny. The weeks following the solar conjunction will be a critical test for all existing theories. Emergence. Assuming 3I Atlas survives its trial by fire, its re-emergence in early November will be the moment of truth. Telescopes worldwide will swing to its expected exit path. Veteran interstellar researchers like Dr. Karen Meach will lead campaigns to recover it, looking for even the faintest signature, perhaps as dim as magnitude plus 24. The most crucial measurement will be astrometry, pinpointing its exact position to within a few milliarc seconds. If the jet has been producing thrust, the comet's path will deviate slightly from a purely gravity-driven orbit. Detecting these non-gravitational forces will be the smoking gun that proves the jet is an active propulsion source. Rapid follow-up spectroscopy will be vital to see if its chemistry was altered by the intense solar heating, perhaps revealing new materials boiled off from its interior. The change in the object, or its stubborn lack of change, will be the key to unlocking this mystery. So, we are left standing at a precipice. A hypothetical object, 3I Atlas, backed by puzzling data from real interstellar visitors, forces us to confront the limits of our knowledge. Is its sunward jet a fleeting natural phenomenon, a sign of exotic chemistry we've never seen before? Or is it something that fundamentally bends the rules of physics, hinting at a purpose beyond natural formation? The period of perihelion blindness leaves us in suspense, but the weeks that follow promise a flood of new data. The answers are waiting out there, in the cold dark of space. What do you think is happening with this object? Let us know in the comments below. And don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our cosmos. Thanks for watching Stellar Tech. A cosmic alignment so perfect it defies chance, or maybe a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but honestly, the evidence points to something far stranger. Let's explore this together. Swan's dramatic arrival. What does it look like when the impossible streaks across the sky? On September 12, 2025, we found out. The SWAN instrument, a solar wind anisotropy sensor aboard the SOHO spacecraft, flagged a new object blazing a path through the inner solar system. The first data sets, analyzed by teams led by SOHO project scientist Bernhard Fleck, were staggering. The object possessed a tail stretching nearly 2.5 degrees across the sky, about 5 times the width of a full moon. To put that in perspective, a tail of that magnitude suggests a hydrogen outgassing rate hundreds of times greater than a typical long-period comet. Its initial brightness was clocked at magnitude 7.4, luminous enough to be seen with backyard telescopes from a distance of over 150 million kilometers. This wasn't some faint smudge. This was a spectacle. News ignited across astronomy networks. And just 2 days later, an amateur observer captured a jaw-dropping image showing a streak so immense it barely fit the camera's frame. It was too big, too bright, and its trajectory was already looking far too precise. The raw energy output required to generate such a visible display at that distance was the first red flag that this was something entirely new. official recognition and growing mystery. A name makes it real, but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN, in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but SWAN was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arc-seconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are so unlikely they stop looking like a coincidence. C/2025 R2. SWAN is not the only strange visitor this October. Days before, another object, 3I/Atlas, was already inbound from a completely different part of the sky. Imagine a celestial map. SWAN's path traces back from Aquarius while Atlas entered from the direction of Sagittarius. Yet both are set to reach their closest pass by the Sun within the same 10-day window. For Atlas, that's October 17th at a distance of 1.36 AU. For SWAN, it's just 3 days later, around October 20th, at a much closer 1.0 AU. Their perihelion points are separated by only about 50 million kilometers, closer than Mars ever gets to Earth. The geometry is what's truly stunning. Both are on steeply inclined orbits, with SWAN's path tilted more than 60 degrees and Atlas nearly 90 degrees to the ecliptic plane. As orbital dynamicist Paul Wiegert would tell you, the statistical probability of this kind of synchronized arrival from such different trajectories is infinitesimally small. It's a corridor in space-time that seems to have been deliberately targeted. This is not random chance, it is a rendezvous. Atlas breaks the rules. So what happens when an object just refuses to follow the laws of physics as we know them? 3I/Atlas first caught astronomers' attention by, well, breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that set off alarms, a body dominated by nickel with virtually no iron, a ratio that's just unheard of in natural celestial objects. This, honestly, contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends, similar to chondritic meteorites. The claim was so radical that, some labs called for immediate data re-verification. But the mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. What couldn't be explained, though, was its motion. Observers noted 3 distinct non-gravitational accelerations, each providing a delta V of several meters per second. These weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object that showed similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and powerful. SWAN, the fortress. If Atlas is a nimble drone, then SWAN is a battleship. The scale of C/2025 R2 is honestly hard to comprehend, but it's the data that paints a radical picture. One that's driven speculators like Harvard's Avi Loeb to consider similar theories for other objects. It all began with reflectance data. SWAN's core has an albedo or reflectivity far higher than a typical dark comet nucleus, matching the signature of polished metal. Some analysts argue it fits a nickel-cobalt blend, an alloy used for its immense strength. Then came reports of a silvery halo around the nucleus, an anomaly some interpret as a plasma envelope, or maybe even an electromagnetic shield. This is where it earned the nickname the Fortress. Unlike Atlas, SWAN appears steady and invulnerable, refusing to fragment as it nears the sun. Even its tail shows evidence of micro-thrusts, tiny, rhythmic pulses at a consistent frequency that just defy natural outgassing. Add in its 22,554-year orbit, and you have an object that appears to be ancient, armored, and on a deliberate, powered course. It isn't just passing through, it's arriving. Mission theories. Coincidence or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really plummet. This has fueled a wave of mission theories. The first and most routine is a scheduled refueling run, with the sun acting as a cosmic pit stop for two engineered probes. A second, less peaceful theory suggests an intervention or even a confrontation, especially given the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I/2017U1, was the first scout, followed by 2I/Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the sun isn't just a backdrop. It's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or energy top-up is standard practice for our own probes, like the Parker Solar Probe, making this theory, well, chillingly plausible. Ancient connections. An orbit of 22,554 years is, a link to a different chapter of human history. The last time Swan would have passed was around 20,000 BCE, the peak of the last glacial maximum. This is where the story connects to Göbekli Tepe, a site in Turkey built around 9500 BCE. Researcher Martin Sweatman has proposed a controversial theory that its pillars are actually an astronomical observatory, recording a cataclysmic comet impact that triggered the Younger Dryas climate shift. He argues that Pillar 43 specifically tracks a long-period celestial object. Mainstream archaeologists, including the site's original lead excavator Klaus Schmidt, strongly disputed this, maintaining the carvings are symbolic. Still, the timing is, honestly, hard to ignore. If Swan is on a recurring path, its last visit coincided with a transformative period for humanity. Whether that is a coincidence or a clue remains a fiercely debated question. It adds a layer of mythic resonance to an unbelievable event, suggesting we may have seen this visitor before. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Swan and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but the timing is incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied, and raw data requests delayed. A handful of telescope allocation reviewers, speaking off the record, have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When the official channels go dark, the people build their own. The blackout order may have silenced major observatories, but it ignited a firestorm in the amateur and independent astronomy communities. Veteran tracker Bill Gray put out a call to arms across public forums: keep your scopes on the sky, log everything, and share the raw data on open-source servers. A distributed web of astronomers with powerful 14 and 20-inch telescopes answered. Collectives like the Ibero Tracker Group in Europe began pooling their photometric and astrometric data feeds. Leaks suggest plans to use radio telescopes to pierce the solar glare. This grassroots effort has become the only real-time source for what might happen during the blackout. It's a powerful narrative of decentralized science, a global network ensuring no data disappears. When Swan and Atlas re-emerge, the first images confirming their post-perihelion behavior might come from a garage, not a government lab. This has become a testament to citizen science. Power estimates and implications. Let's talk about the energy because the numbers are staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, The energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants like the Palo Verde generating station. But SWAN makes that number look insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that forces us to question everything we thought we knew about our place in the universe. The facts are as clear as they are unnerving. Two anomalous objects defying all statistical odds have entered our solar system on a synchronized path. One appears to be a powered drone, the other an armored fortress. They are scheduled for a close encounter during a 10-day window where they will be conveniently hidden from our best telescopes by the sun, accompanied by an official, top-down order for radio silence. This has forced the search for answers into the hands of a global network of citizen scientists. Are we witnessing a cosmic accident, a pre-planned mission, or something else entirely? Whatever the truth is, we are about to find out. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Simply Science. A Harvard scientist is sounding the alarm. An interstellar visitor, 3I Atlas, is shedding metallic alloys that just shouldn't exist. Real data from our best telescopes shows atomized nickel streaming from its core, but with practically zero iron. A chemical fingerprint that really, honestly, defies everything we know. Harvard's Avi Loeb is asking the question no one else wants to. If these metals aren't natural, what does that mean? The answer could upend our place in the universe, so let's explore this together. The discovery of 3I Atlas. What would you do if you saw something moving at 130,000 miles per hour that wasn't supposed to be there? On July 1, 2025, the Atlas survey team in Chile spotted a faint, fast-moving speck. The math instantly told a story that didn't fit any known playbook. Its path wasn't just a long loop, it was hyperbolic, with an extreme eccentricity that confirmed it was a visitor from deep space, moving too fast for the sun to ever capture it. This wasn't a comet on a return trip. Astronomers combed through archival data and found earlier images firming up its trajectory. The object was born far beyond our solar system, possibly somewhere near the galactic center. By the time it was discovered, it was already inside Jupiter's orbit, making a one-time slingshot around our sun before it shoots back into the void. Its incredible velocity confirmed it. 3I Atlas is only the third confirmed interstellar object ever seen, a messenger from another star that will never return. This isn't just a rock, it's a clue from an unknown part of the galaxy. The nickel mystery. Here's where the story takes a sharp turn into the unknown. Almost as soon as telescopes focused on 3I Atlas, they saw something that shouldn't be there. Data from the Very Large Telescope in Chile revealed a strong spectral line for nickel, a cloud of it vaporizing off the object's core. But what was missing is what has scientists stunned. There was virtually no iron. That's not just unusual, it's unheard of. In every comet, asteroid, and meteorite we have ever studied, nickel and iron are cosmic partners. They are forged together in the hearts of dying stars and locked into the same minerals. You don't find one without the other. Yet 3I Atlas is shedding pure nickel vapor, with iron being conspicuously absent. Harvard astrophysicist Avi Loeb, known for his bold theories, was the first to publicly highlight how bizarre this is. He argues that separating nickel from iron on an industrial scale is difficult on Earth. In nature, it's considered next to impossible. This isn't just a small anomaly. The nickel-to-iron ratio in typical solar system objects is well established. On 3I Atlas, that ratio is completely off the charts. It's a chemical fingerprint that matches nothing we have ever seen. Carbon dioxide dominance. Just when the nickel-iron problem had scientists scrambling, the James Webb Space Telescope delivered another bombshell. Pointing its powerful infrared instruments at 3I Atlas, a team of astronomers analyzed the gases in its coma and found that carbon dioxide was completely dominating the mix. The measured carbon dioxide to water ratio was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put that in perspective, typical solar system comets have CO2 levels around 4% of their water content. Here, CO2 is the main ingredient. This wasn't a fluke. The readings remained consistent across multiple observation sessions as the object neared the sun. While other gases like carbon monoxide were present, nothing came close to the CO2 spike. This kind of chemistry just doesn't align with our models of comet formation. Some researchers propose that its unique composition is the result of being cooked by cosmic rays over a billion-year journey. Others wonder if it's a clue to the specific conditions of its home star system. But the question remains, does this unprecedented chemistry point to nature at its most extreme, or is it another sign that something else is at play? The Oumuamua precedent. This isn't the first time an interstellar visitor has, broken all the rules. Back in 2017, the first ever confirmed interstellar object named Oumuamua left astronomers scratching their heads. It was traveling at high speed, had a bizarre, highly elongated shape, and most mysteriously, it accelerated away from the sun without any visible reason. Comets accelerate due to outgassing, where melting ice acts like a thruster, but Oumuamua had no visible tail or coma. This is where Harvard's Avi Loeb first entered the public debate. He controversially suggested that the best explanation for Oumuamua's non-gravitational acceleration was that it was an artificial object, perhaps an alien solar sail designed to ride the pressure of starlight. While most of the scientific community proposed natural explanations like outgassing of hydrogen ice or its composition as a nitrogen iceberg, none of the theories perfectly fit all the observations. Oumuamua left our solar system before we could get a better look, leaving a legacy of unanswered questions. Its appearance primed the scientific community to expect the unexpected. Now, with 3I Atlas we have a second data point that honestly defies easy explanation. Ancient sky metal. Humanity's fascination with metals that fall from the sky is not new. It's ancient. Over 5,000 years ago, in ancient Egypt, craftsmen hammered tiny beads from a mysterious iron that they didn't mine from the earth. Modern analysis of these beads from the Gertze cemetery reveals a nickel content of nearly 30%, far higher than any terrestrial ore. This was the unmistakable signature of meteoritic iron. The story gets even more incredible with the dagger found in the tomb of King Tutankhamun. Discovered in 1925, the pristine iron blade was a mystery for decades. Finally, X-ray analysis confirmed its celestial origin. The blade contained 11% nickel and traces of cobalt, a composition that matched iron meteorites. The Egyptians even had a name for this divine material, iron of the sky. It was rarer and more valuable than gold, reserved for pharaohs. This history matters because it establishes a fundamental contrast. Terrestrial iron ores almost never exceed 4% nickel. Meteoritic iron, however, is rich in it. The same questions our ancestors faced, what is this strange metal and where did it come from, are echoing today as we analyze the impossible alloys of 3I Atlas. Kilonova formation theory. So, if the metals on 3I Atlas are natural, how could they have formed? There are a couple of cosmic forges violent enough to potentially create such exotic materials. The first is a kilonova, the cataclysmic explosion that occurs when two neutron stars collide. These events are among the most powerful in the universe, and for a few brief seconds, they create conditions perfect for the R process, a rapid-fire sequence of neutron captures that forges elements heavier than iron. In the chaos of a kilonova, the normal rules of element production can be broken. Some theoretical models predict that the debris cloud from such a merger wouldn't be uniform. Instead, it could contain pockets of matter with strange elemental imbalances, regions that are incredibly rich in elements like nickel but poor in iron. If 3I Atlas condensed from one of these exotic debris patches millions of years ago, it would carry a chemical signature unlike anything from a standard supernova or our own solar system's formation. This theory provides a potential natural explanation, but it relies on an event that is both incredibly rare and violent. Asymmetric supernova theory. There is another natural forge in the cosmos, violent enough to potentially explain 3I Atlas's strange chemistry, an asymmetric supernova. Not all stars die in neat spherical explosions. Some rip themselves apart in lopsided blasts that fling elements out in jets. The supernova remnant W49b is a perfect example. X-ray maps of W49b from the Chandra Observatory show that iron is packed tightly near the remnant's core, while other elements like sulfur and silicon are distributed more broadly. This kind of uneven explosion, well, it completely changes the rules of how metals are scattered into space. In these chaotic events, the inner layers of the star, where iron and nickel are made, don't mix evenly. Instead, high-speed plumes can punch through the star's outer layers, carrying specific elements with them. If nickel happens to be concentrated in the path of one of these jets, it can be ejected in bulk, leaving most of the iron trapped behind. If 3 I Atlas formed from a fragment blasted out by such a supernova, it could have started its journey as a chunk of nearly pure nickel. This provides a second plausible, though very rare, natural path to its bizarre composition. Statistical improbability. Beyond its strange chemistry, there's another red flag that has Avi Loeb and others asking, some serious questions: the object's trajectory. According to Loeb, the probability of a random interstellar object passing so close to several planets in our solar system, Venus, Mars, and Jupiter, in a single flyby is, well, astronomically low. His calculations put the odds at about 1 in 20,000 or 0.005%. For an event this rare to happen with only the third interstellar object we've ever detected is, to him, statistically suspect. Furthermore, the object's path is nearly aligned with the plane of our solar system, but it's moving in the opposite direction of the planets. This retrograde orbit allows it to sweep past the inner worlds in a way that looks almost like a survey mission. To add to the suspicion, 3 I Atlas reaches its closest point to the Sun on the far side from Earth, making it incredibly difficult for us to observe when it's most active. Critics argue that in a vast universe, rare events are bound to happen. But Loeb counters that when multiple anomalies, the metals, the chemistry, and the trajectory, all point in the same strange direction, the possibility of an artificial origin must be taken seriously. The Golden Record Parallel. Could 3 I Atlas be a message in a bottle? In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by Carl Sagan, intended as a time capsule for any extraterrestrial civilization that might find it thousands of years from now. The records contain sounds and images of Earth, music from various cultures, and scientific diagrams, a snapshot of humanity etched onto a durable physical object. Sagan said, "The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." Now consider 3 I Atlas, an object loaded with alloys and compounds that don't fit natural recipes, on a trajectory that seems too precise. The parallel is honestly striking. What if its message isn't written in grooves on a record, but in the very ratios of its elements? A physical archive designed to survive a journey of millions of years. If its composition is intentional, then 3 I Atlas isn't just a visitor, it's a courier carrying a record of another world's chemistry, and maybe even its technology. Atomic messages. If 3 I Atlas is a message, how could it be written? The answer might lie in isotopic encoding. Isotopes are versions of an element with different numbers of neutrons. On Earth, scientists can already store information at the molecular level by creating unique isotopic fingerprints. By precisely controlling the ratios of different isotopes in a material, you can create a pattern, a kind of atomic QR code that would never occur in nature. An advanced civilization could theoretically bake a message into a metallic object, making it durable enough to survive a journey of millions of years through interstellar space. Such a message would be immune to the cosmic noise that can degrade radio signals. The information would be in the fine print of the object's chemistry. This is why every scrap of data from 3 I Atlas is being scoured for these hidden patterns. Are the isotope ratios what we'd expect from a kilonova, or do they show a level of order that points to intelligent design? We're not just looking for a rock anymore, we're looking for a signal hidden in matter itself, a message that has waited eons to be read. The story of 3 I Atlas leaves us at a profound crossroads. On one hand, we may be witnessing an undiscovered, violent natural process, a kilonova or an asymmetric supernova capable of creating alloys we once thought impossible. On the other hand, the combination of inexplicable metals, extreme chemistry, and a statistically improbable trajectory has forced serious scientists like Avi Loeb to consider an engineered origin. This isn't just a theoretical debate, it's a real object with real data that is breaking our models of the universe. Either way, our understanding has to expand. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Simply Science.